Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And the puzzle's called Sigma by Kaktuslav. And Sigma is usually it's a symbol that usually represents a sum. And I think that's what it's representing here. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Each pink line is a Renban. That is, it contains a set of consecutive digits in any order. So, for example, if this were, say, a 6, this would have to be 5 or 7, because these have to form a consecutive set of digits in any order. But we also have no two pink lines have the same digit sum. I don't know what that means by digit sum. I think it just means basically the sum of its digits, right? It should be just the... You should be able to just say, like, this. No two pink lines have the same sum, right? Oh, I guess it does make sense, because you're not usually adding digits on a Renban. So saying it has the same digit sum, I guess, is a quick way of saying just add up all the digits and then sum them together, and then none of the Renban lines have the same sum in that instance. So I guess that makes sense, because usually you're not summing the digits on a Renban line. So because of that, then it makes sense to basically say the digit sum, right? So no two pink lines. If you sum up their digits on the line, no two lines will have the same sum. So keep that. So for example, this would be the digit sum of 13 here for this line, if this were 6 and 7. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, for every 3 cells, and since these are all in the same row, this must be the sum of, you have to have 1, 2, 3. So 1 has to be on the Renban, and it must be with 2 and 3. 9 has to be on a Renban, it must be with 8 and 7, so the remaining Renban is 4, 5, and 6. So that means this combination is, one of them is going to be the sum, is going to add up to 6. So one of them's adding up to 6 here. The other ones are adding up to 15 and 24 for these sets. How many lines do we have? We have 1, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 lines. For the 2-digit ones, you can start with 1 and 2. You have 1, 2, 2, 3, 3, 4. They're all going to be odd numbers, right? So 1, 2 adds up to 3. 2, 3 adds up to 5. 3, 4 adds up to 7. And then we have all the way up to 17. But we definitely have 15 in one of these 3 Renbans, because it has to be 4, 5, and 6 adding up together. For Renbans on the same row, it has to be either 1, 2, 3, 4, and 5, 6, 7, 8, 1, 2, 3, 4, and 6, 7, 8, 9, or 2, 3, 4, 5, 6, 7, 8, 9. Oh. So actually, that's all the combinations. We have 1, 2, 3, 4 with 5, 6, 7, 8. And 2, 3, 4, 5 with 6, 7, 8, 9. Right. So then these have to be 1, 2, 3, 4. So one of them is 10 with 5, 6, 7, 8. Because the thing is, we can't have 1, 2, 3. So 2 through 5 guarantees one has to be from 6 through 9. 6 through the 5 through 8 guarantees that one has to be 1 through 4. And since we can't have a repeat sum, you can't have 6, 7, 8, 9 twice. You have to have one has to be 1, 2, 3, 4. One has to be 2, 3, 4, 5. One has to be 5, 6, 7, 8, and the other one has to be 6, 7, 8, and 9 because they're in the same row. So 1, 2, 3, 4, and 2, 3, 4, 5 is 4. So it would not be with 2, 3, 4, 5. It would have to be with 5, 6, 7, 8 specifically, which is 26. And then you have 2, 3, 4, 5, which is 14. And 30 for 6, 7, 8, 9. So those are the definite sums you have. Two-digit sums always are going to add. Okay, so four-digit sums. Interesting. Two-digit sums always will sum up to an odd number. And four-digit sums always add up to an even number. Three-digit sums can be either odd or even, so we're not sure about that. So the combination of digits here is interesting. For the two digits, we can have 3, 5, 7, 9, 11, 13, no 15, and 17. So there's 7 possibilities. And we only have 6 of them accounted for. For 4 digits also. Okay, so these combinations are either 1 through 4 and 5 through 8, which means 9 is left over, or 2 through 5. So this has to be a 1-9 pair here. So, sorry, not a 1-9 pair, but one of these is 1 or 9, and this has to be 1 or 9. Guaranteed. We have 2 more sets of 4 digits. So we have 1 accounted for, 2 accounted for. So starting at 1 as the lowest digit, 2 starting at 2 at the lowest digit, 5 and 6. So the other ones must be starting at 3 and starting at 4. Okay. Starting at 3 is 3, 4, 5, 6, 7. Sorry, 3, 4, 5, 6, which is 18. So one of these is 18, and then the other one must be 4, 5, 6, 7, which is 22. So for the 4-digit numbers, we have all of them accounted for. So we know these are guaranteed to be what? 3, 4, 5, 6 or 4, 5, 6, 7. Which means we have a 3, 4, 5, 6, 7 quadruplet. Actually, this has to be whatever digit is not here. So this is guaranteed to have 4, 5, and 6, right? Because these are combinations of it either is 1 through 4 with 5 through 8, or 2 through 6. 1 through 4 with 5 through 8, or 2 through 5 with 6 through 9. So this is guaranteed to have 4, 5, and 6. So it cannot be 4, 5, and 6 here. Which means this has to be a 4, 5, 6 triplet here. Because it has to be either 3, 4, 5, 6 or 4, 5, 6, 7 here. And the extra 3 or 7 is here. That means the remaining digits in this box are 1, 2, 8, and 9. So we are guaranteed this cannot be 1 or... This is 1 or 9 here. This is 1 or 9 here. We have a 1, 2, 8, 9 quadruplet in box 9. So this can't be 1, 2, 8, 9. This is 3, 4, 5, 6, 7. This can't be 2 or 8 because the 2 or 8 in the row has to be in one, or in this box has to be in these cells here, which means that can't be in the row. So this digit is the same as that. And it cannot be the same as that digit there. So these digits are the same. And it has to then be one of these two digits here, interestingly enough. So that means this one obviously cannot be here. So it has to be one of these three here. Okay. So it must be one of these three. Obviously, we cannot have 4, 5, 6 here. So the remaining digits in this column are 1, 2, 3, 7, 8, 9. So this could be, this is 6 total. So what do we have for certain? For the 4s, we have 10, 10, 14, 18, 22, 26, and 30. When we have for the 3s, we definitely have 6, 5, and 21, 24. Sorry, 6, 15, and 24. So this can never be 4, 5, and 6. For the remaining 3 cell digits, what can they be? So you have 1, 2, 3 adding up to 6, 2, 3, 4. Okay, so let's list out all of them right now. For the 2-digit numbers, we have what? We have 3, 5, 7, 9, 11, 13, and 17. For the remaining 3-digit numbers, we have 1, 2, 3 already. 2, 3, 4 is 9, which repeats there. 2, 3, 4 is 9. 3, 4, 5 is 12. 4, 5, 6 we already have. 5, 6, 7 is 18. Okay, so we don't have 18 available because we are guaranteed all of these for the 4-digit numbers. So then it's 21. And then, yeah, so the remaining digits. Okay, so then that gives us all the information we need then. So for the remaining 3-digit numbers, we have 9, 12, and 21, which is 2, 3, 4, 3, 4, 5, and 6, 7, 8. Because, so again, we have to have all 6 four-length Ren bands, which is 10, 14, 18, 22, 26, and 30. 30, not 3. So And the 3 that we definitely have for 3 digits is 6, 15, and 24. The 2 digits can be 3, 5, 7, 9, 11, 13, and 17 because 15 is already definitely taken. And for the remaining 3-digit sums, we have it's at 6, 9, 12. So we have 9, 12 available. 15 is already guaranteed. 18 is already taken by the 4-digit numbers. And then the other one left is 21. So again, we have 2, 3, 4 and 3, 4, 5 available, and then 6, 7, 8. Well, these two cannot be both 2, 3, 4 and 3, 4, 5 because they would have 5 digits that would be different when 2, 3, 4 and 3, 4, 5 are definitely not different. Same with these. These would have so this has to be some combination of either 2, 3, 4 here, and the problem is okay. If we try to have 2, 3, 4 here, that would mean one of these would have to be 3, 4, 5, but this having 3 digits here and 2 digits different here does not work because 2, 3, 4, 5 is only 4 digits. So this can't be 2, 3, 4. Same with this being 3, 4, 5 because then it shares the same row with this. So this is a combination of 2, 3, 4 or 3, 4, 5 with 6, 7, 8. And therefore this has to be 6, 7, 8 here. So since this is 6, 7, 8, this must be one of these is 2, 3, 4 or 3, 4, 5. So we have so we know all the 3 digits are 9, 12, 21, 6, 15, and 24. That means we cannot have a 9 for the 2-digit number. So all the 2-digit numbers are 3, 5, 7, 11, 13, 17. Okay. So then let's remove these so we can put all of these in the same place. So we have 6, 9, 12, 15, 21, and 24 for the 3-digit numbers. For the 3-digit Ren bands. For the 2-digit Ren bands, we have 3, 5, 7, no 9, 11, 13, and 17. So this is guaranteed to be 6, 7, 8. We have to have, this is 2 through 5 here, and this must be 2 through 5 here. Either way, this can't be 3 or 4. And the 6, 7, 8 triplet eliminates 6, 7, 8 in the rest of the box. Therefore, 9 can't be here. Where is 9 in box 1? It has to be here. So this is 9, which makes this 1. This cannot be 9. This must be 1, 2, 3 as a triplet here, which eliminates 1, 2, 3 in the rest of the row. So no 2, 3 here. This is 4, 5 as a pair, which forces this to be 3. So then this can't be 3 here. This has to be 2, 3, 4 as a triplet here because we have 2 and 4 required to be there, and we already have a 3, 4, 5 Ren band here. So then this is 3 here. This is 2 or 4, so this cannot be 4, 5, 6 here. This is 7, 8, 9 here. Okay. So that means this is 7, 8, 9, and this must be 4, 5, 6 here. This has to be a different digit, so these are both 9. So we have 9 here, 9 here. This must contain 5, 6 through 9, or 2 through 5. And therefore, this must be 2 through 5 here, because we can't have an 8 or 9 there. That 3, 4, 5 triplet eliminates 3, 4, 5 in the rest of the box. This is then a 2. So this is 2. This has to be 6, 7, 8, 9. And this is 6, 7, which must be with 5, 6, 4, 5 here, sorry. That eliminates 4, 5 in the rest of the box. This has to be 1 through... No, this is not 4, 5. It's 5, 8 here. This is 5, 8 to be adding up with 6, 7. That eliminates 9 here. This cannot be 5. This is 1 through 4 here. So here we have 1 through 4, no 4, no 1 here. So this has to be 1 here, which means no reds there. So we can remove the coloring. No 4 here. This can't have 4 here. It must be 6 through 9. So no 9 here. No 8 here because of the 5-8 pair in the box. So this is 6, 7 as a pair, which eliminates 6, 7 in the rest of the box. It also eliminates 6, 7 here. So this is 3, 4 as a red band, which makes this 5, 6, which forces this to be 7. 7 eliminates 7 here, so that's 8, which eliminates 8 in the rest of the box. This can't be 1, so this must be a 2, 3 pair here. Okay. The remaining digits in row 2, we have 1, 5, and 9. So this can't be 7, 8, 9 because of the 7, 8, 9 triplet. And this can't be 1 because of 1 in the column, so this is 5. That leaves 1 and 9 remaining. This can't be 9 because of 9 in the column. So that's 1, which makes that 9. That eliminates 1 there. The remaining digits in 2 eliminates 2 here. So this is 4 and 2. This cannot contain a 1 because 1 is only consecutive with 2, and we already have a 2 in the column. So 1 has to be here, which leaves this as a 6. Oh, so that does become 6 with 5 or 7. That's 12 or 11 or 13, so that's fine. Remaining digits of box 4. We have 1, 2, 3, and 7, 8, 9. 2 cannot be here because that would guarantee we need to have a 1 or 3 to be consecutive with that. So there's no 2 here, which means this has to have a 2 here. 1 could have a 2 here. 3 could have a 3 eliminates 3 here. So this is 4, which makes that 3. So we have only 1 out of 1 or 3 here. So this can't be 2 because of 2 in the column. This can't be 2 because of 2 in the column. So here, the remaining digits are, one of them's 2, which can be with 1 out of 1 or 3. But the only remaining digits can be here are 6 through 9. So 2 out of 7, 8, or 9 are here. This is 8 or 9. So 2 out of 7, 8, or 9 are here. And then 1 of 8 of 9 is there. So this cannot be 7, 8, or 9. It's 6, which makes that 7. 6 eliminates 6 here, so it's 5 and 6. 5 eliminates 5 here, so it's 4 and 5. That eliminates 4 here. So what are the 2-digit numbers remaining? We have 3, which is 1 and 2. 5, which is 2 and 3. 7, which is 3 and 4. But 3 and 4 can't be here, and 3 and 4 can't be here, so where's the 3 and 4? They have to be here, which eliminates 3 and 4 in the rest of the column. This can't be 3 or 4. It's 5. That eliminates 5 there, so it's 6, which eliminates 6 here, so it's 7, which makes that 6. So these can't be 5 anymore. This 3 eliminates 3 here, so that's 4, which makes that 3. This can't be 4 or 6, so it's 5, which means this can't be 6 or 5. It's 4. We need a 5, 6. 5, 4 is not valid as a 2-digit red band because we already have 2, 3, 4 adding up to 9. So this can't be 5 here, this can't be 5 here, this must be 5 there. That eliminates 5 in the rest of the column, so this is 8 and 5. 8 and 9 eliminate 8 and 9 in the rest of the column, so that's 7. There's no 7 here, no 7 here. So we have 11 accounted for and 7. We still need 8 and 9. Okay, remaining digits in row 3, we have 2, 7, 8. Okay, so no 7 here because of the 7 in the column. 3, 4 as a pair means this can't be 3 or 4, so it's 1, 2, or 8. Ren band here could be 1, 2, 7, 8, or 8, 9. Okay, remaining digits in column 6 are 1 and 3. 5 here eliminates 5 in the rest of the box. We have a 1, 3, 3, 4 pair in row. So this is in row 5 and 6. So we have guaranteed a 3 in one of these cells. We are guaranteed a 3 in one of these cells, which eliminates 3 in the rest of rows 5 and 6. So where's 3 in box 4? It must be here. And in addition, this is 2, 3 as a pair, so this can't be 3. This is 4. In addition, we still need 3, 2, and 1, 2 as a pair for the Ren band. Well, this must then be 3, 2, because that's the only other place for it. So that's 3, that's 2, which means this can't be 2 or 3 here. And this can't be 2, but we need a 1, 2 pair. These can't be 2 anymore, so this can't be 1 and 2. So that means this must be a 1, 2 pair here. So this is 1 and this is 2, which means this can't be 1 or 2, it's 8. This can't be 2 or 8, it's 7. This can't be 1, 2, 7, or 8, it's 9. So 7 eliminates 7 here. 8 eliminates 8 here, so that's 2, which makes this 1. 2 eliminates 2 here, so it's 8, which makes that 2. This can't be 1 or 2, it's 8. 1 and 8 are eliminated here. 7 eliminates 7 here. So this can't be 1 or 8, it's 9. Therefore, there's no more 9 in the rest of the box. 3 here eliminates 3 here, so that's 2, which makes this 3. 3 eliminates 3 here, so that's 2, which eliminates 2 here. And this 3 eliminates 3 here, so that's 1, which makes that 3. And this can't be 2 because of 2 in the row. So it can't be 8 because of the 7, 8 pair in the box. So this must be 1, and this must be 2. 9 eliminates 9 here, so it's 8 and 9. And again, this cannot have a 9 here. We cannot add up to 15, so 7 and 8 are removed. So it must be 6, 7, and 7, 9, or 8, 9 remaining. Well, this can only be 8, 9 here, so then this must be 7 and 6. 1 eliminates 1 here, so it's 3 and 1. 3 eliminates 3 here, so it's 4 and 3. And we have 9 here, eliminating 9 here, so it's 8 and 9. 6 eliminates 6 here, so it's 7 and 6. And the rest we do just from normal Sudoku. No 4 here, no 6 here. We should have all the 1s. We do. We have all the 2s. We have all the 3s. 4s are not quite restrictive enough. Neither are 5s. What about 6s? Neither are 6s. Okay, remaining digits in... We do have enough 8s. So we have 8 8s, so the remaining 8 has to be here. We have all the 9s, though. So this must be 4, 5 as a pair in row 6, but this can't be 4 because of 4 in the column. So this is 5, which makes this 4, which makes that 6, which makes that 5. And so... remaining digits, we have 8 4s. This must be 4 here. So we did 5. We have all the 5s now. Do we have all the 6s? No, but this is the last 6, which leaves these as 7. And that's a solution. Not too bad. The logic was fairly straightforward. I don't know, maybe it's a little harder for those who don't have these sort of like I've done so many like Killer Cage Sudokus or arrows or basically mainly actually probably Killer Cage Sudoku because you have to add up all these very quickly and be able to sort of spot these what can be where, right? And so the Ren bands were fairly easy to determine what the sums were. I don't know. Seems pretty straightforward. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.